So in this video, we're going to go over special right triangles. So there are two special right triangles that we have. We have our, what's known as the 30, 60, 90. And there's going to be something that is special about this triangle and all right triangles with these three interior angle measures. So we're going to study that now because it becomes very important in trigonometry. Okay? So in order to find information out about a 30, 60, 90, okay, we're going to start by making an equilateral triangle. Now remember, an equilateral triangle is also equiangular, okay, and from this we're going to build to this special right triangle, the 30, 60, 90. Okay, so if I take an equilateral triangle, okay, triangle ABC is equilateral. So what that means is all three sides have the exact same length. So I'm just going to give an expression for one side. Okay, so if I say that the length of this side is 2x, that means the length of this side is 2x and the length of this side is 2x. You might be saying, why did you have to make it something like 2x? It's just so that in a minute it's a little bit easier on you. Okay, so now what we're going to do is, if it's also equiangular, that means interior angle sum of a triangle is 180. That means each angle inside is 60 degrees. Now, what I'm going to do is I'm going to draw an altitude, so you should remember that from geometry, coming from point B. Now, there's something special about an altitude of an equilateral triangle. An altitude of an equilateral triangle is also the perpendicular bisector of the opposite side. So I'm going to draw in here, okay? I'm going to draw in here the altitude. Now, what that's created is, this is 90 degrees, and this portion from A to here and C to here are the same length. Okay? So now, think about this. Okay? If I were to zoom in on this triangle here, I have two triangles I've created now. Okay? If I was to zoom in on this triangle right here, if this length was worth 2x, if AC was worth 2x, and this altitude just cut this in half, then what is this worth? It's worth x, because this is worth x. And if this is 60, this is 90, okay? If this is the perpendicular bisector, we know that not only is it the perpendicular bisector, it's also the angle bisector if it's an equilateral triangle. So this angle inside of this right triangle right here is actually 30 degrees. So what I now have is a 30, 60, 90 degree triangle where this is worth x, this is worth 2x, right? This was A, this was B, this was A, this was B, and we could call the altitude, if I put D there, we'll draw altitude is segment BD. Okay, there's a D here. So what this is saying is, the side that's opposite 30 degrees, whatever it is, the 90 degree, the side that's opposite 90 degree is always going to be double that. Now, let's figure out what is the length of side BD. Okay, so we're going to use Pythagorean theorem here. So we know that this plus this squared plus this squared equals this squared. So we know that x squared plus bd squared equals 2x. Now I'm going to put this in parentheses so we don't get confused here, because it's the expression this side squared plus this side squared equals this side squared. Okay? So now if we simplify this, this is x squared plus the unknown is BD, right? And 2x squared, 2x times 2x, that's 4x squared. And we're trying to solve for the side BD. We want to know, what is this expression? Okay, this is what we want to know right now. What is that expression on the side that's opposite 60? Okay, so we want to get BD by itself. So we take away x squared on both sides. And that gives us BD squared equals 3x squared. So we don't want BD being squared, so we take the square root of both sides. And we get side BD, now it would be plus or minus, but a side length can't be negative, so it's only going to be positive here. The square root of 3x squared, okay, and this can be simplified. This is the same as the square root of 3 times the square root of x squared. And the square root of x squared is just x, but you could not simplify the square root of 3 at all. So side length BD is equal to x square root 3. Okay, so this is true. This is what's so special about a 30, 60, 90 triangle. This right here, okay? What this is saying is, whatever is opposite 30, okay, so notice opposite 30 right now is just x. So that could be any value at all. What that's saying is, whatever is opposite 60, the side length will always be whatever was opposite 30 times the square root of 3. And then opposite 90, the side length will always be double of whatever opposite 30 degree is, okay? So that's extremely, extremely important. You have to remember that, okay? That is something you must remember, okay? A 30, 60, 90 degree triangle okay? Whatever is opposite 30, now if you don't like, people get confused because I put x here. If you don't like having x, put any symbol to represent a variable, has the ability to change. Whatever is opposite 30, okay, the value that will always be opposite 60 will always be that times the square root of 3. And opposite 90 will always be double what's opposite 30 degrees, okay? And how did we find this out? We found this out by taking an equilateral triangle and actually putting in one of its altitudes. You create two 30, 60, 90 degree triangles. Okay, so that's how you could prove this. So now we're going to use this to solve for missing pieces of a 30, 60, 90 triangle. So that's what we'll do now. Okay, so here are three problems in which we have to solve for the missing side lengths of each triangle. The big picture, okay, that you have to remember is, first off, you need to make sure that these are right triangles, okay? And then take a look at the information you have. Every triangle has 6 pieces of information to it, 3 interior angles and 3 side lengths. So look at what you have. You have a 30, 60, 90 right triangle here. So that means you have a special right triangle. So you have all the interior angles, and then you have a side length of 4. And the side length of 4 is opposite what angle? It's opposite 30 degrees, okay? So remember, 30 degrees, whatever is opposite 30 degrees, opposite 60 degrees will always be that times the square root of 3. So A is just whatever this is times the square root of 3. So the length of A, okay, is 4 square root 3. B is opposite what angle? Side right here, this side length B is the hypotenuse. It's opposite 90. So whatever is 30 degrees, okay, whatever is opposite 30 degrees, opposite 90 is always double that. So that's going to be 2 times 4, which is 8. So A has a side length of 4 square root 3, and B has a side length of 8. Okay? In the next problem, we have a 30, 60, 90 special right triangle, and we have what's opposite 60 degrees. Okay? Opposite 60 degrees is 10. Okay? So, if you have to think of this, if 30 degrees is what x is, and 60 degrees is what x square root of 3 is, how do you get to know what's opposite 30 if you know what's opposite 60? Well, how do you go from 60 degrees to 30 degrees here? You would be dividing by the square root of 3. So you have to take, to find out what's opposite 30, you have to take 10 and divide it by the square root of 3. Okay, that's going to be what's opposite 30 here. Okay, so now we have to rationalize our denominator. We don't want to keep a square root sitting in the denominator of our fraction. So what we do is we multiply the square root of 3, 10 over the square root of 3 by the square root of 3 over the square root of 3. Okay, that's going to give us 10 square root of 3 over 3. And that can't be simplified any further. I'll go like this so I don't confuse anyone. So opposite 30 is 10 square root 3 over 3. Okay, so to get from 60 to 30, you had to divide by the square root of 3. Think about it. To get from 30 to 60, you had to multiply by the square root of 3. So if you had to go backwards, you'd have to divide by the square root of 3. And then 90 degrees is always doubling whatever 30 is opposite 30. So if this is opposite 30, then to get what's opposite 90, we have to double it. So that would be just 20 over the square root of 20 square root of 3 over 3. Okay, if you were able to simplify this fraction, the only thing you would be able to simplify is if 10/3 had a common factor, okay? Square root of 3 is not going to be a factor with anything because it's under a square root. Same with 20/3, nothing to simplify there. Moving on to number 3, we have another 30, 60, 90 degree right triangle. And we have the length that's opposite 90. Okay, remember 90 degrees is 2x if we were to compare it to saying whatever's opposite 30. So how do we go from, if we have the 90 degree angle, how do we go to knowing what the 30 degree angle is? Well, we know that we have to divide by 2. So if the 90 degree angle is 20 square root 2, how do we get the 30 degree angle? We divide it by 2. That's going to give us the opposite 30, which is n, okay? And now simplify that, 20 divided by 2, 10 square root 2. So n has a length of 10 square root 2. Now, how do you get this? What's opposite 60? You take whatever's opposite 30, and you multiply by the square root of 3. So to get what's opposite 60, we take 10 square root 2, and we multiply by the square root of 3, which would just be 10 square root 6, and the square root of 6 can't be simplified. Okay, so remember, if you don't have what's given 30, and you have, say, what's given 60, to get from 60 to 30, you divide by the square root of 3. If you have what's opposite 90, to get to what's opposite 30, you divide by 2. Okay, so this is the 30, 60, 90, and now let's move on to the second special right triangle. Our second special right triangle has interior measures 45, 45, 90. This is actually an isosceles right triangle. Okay, so if I was to draw this, doing my best here, a triangle ABC. If this was a 45, 45, 90, you never make assumptions based on the picture. You always just go by what facts are given to you. We know it's a 45, 45, 90, so when the angle measures, interior angle measures here are the same, that means these lengths are equal. Okay, so I'm just going to give an expression for side length AC. I'm just going to call the length of AC x. Okay, remember isosceles here, these two are the same length, so AC, whatever the length of AC is, that's the length of AB. So this has a length of x. So right now, we just don't know what the length of BC is, which is the hypotenuse of this 45, 45, 90. So we're just going to do Pythagorean theorem because we have 2 of the 3 side lengths. So we know that the side length of AC squared plus the side length of AB squared equals side length BC squared. So x squared plus x squared equals side length BC squared, and that's the side that we want to find the expression for. Okay? Notice it's not going to be just a number, it's going to be an expression in terms of x. So that's just x squared plus x squared equals BC squared. x squared plus x squared. That's 2x squared equals bc squared. We take the square root of both sides so that we get bc by itself. Okay. Now technically, when you take the square root of an unknown squared, you get the positive and negative of this root. But since we're talking about a triangle's side length, it can't be negative, it can only be positive. So we just have positive square root of 2x squared. This can simplify to be the square root of 2 times the square root of x squared, which simplifies to be x times the square root of 2. Okay, so this is true about all 45, 45, 90 triangles, right triangles. Oops, I'm going to redraw that. That was a mess. Okay. We're going to pretend that my drawing skills are a little better than that. So whatever is opposite the 45-degree angle, okay, opposite 90 will always be that times the square root of 2. This is true about all 45, 45, 90 triangles. Whatever is opposite 45, okay, the 45 angle, opposite 90 will always be that times the square root of 2. So let's say you want to work backwards. If you know you have a 45, 45, 90, and you have what's opposite 90, okay, you know if you divide that by the square root of 2, you would be at the 45-degree side length. What's opposite 45? Okay, so this is true about all 45, 45, 90 right triangles. Okay, so now we'll do a few problems with 45, 45, 90. Okay, so we have two triangles here. Solve for the missing side lengths. So notice what you have. You have a right triangle, and it's a special right triangle, 45, 45, 90. And you don't have two side lengths, but you have one side length. And the one side length that you have is opposite 45 degrees. So you know then that the other angle, 45 degrees, whatever's opposite that, they have to be the same. So you know that here y is 10. And then the side length that's opposite 90 is referenced as x here. And you know that opposite 90 is always whatever opposite 45 times the square root of 2. So this is just 10 square root 2. Okay. Number 2, you have a 45, 45, 90. You have what's opposite 90. Remember, whatever is opposite 90 is x times the square root of 2. If you want to get what's 45 degrees, you need to divide by the square root of 2. Okay? So we need to take 21 and divide it by the square root of 2, and that's going to be what's opposite 45. So that's going to be what's A and what's B. Okay? So we rationalize because we don't want to leave an irrational value in the denominator of a fraction. So we simplify this expression by multiplying by a clever form of 1. Our clever form of 1 here will be square root of 2 over square root of 2. That's going to be 21 square root of 2 over the square root of 2 times the square root of 2 is 2. 21 halves can't be simplified, so A is 21 square root of 2 over 2, and B is 21 square root of 2 over 2. Okay, and that is it for special right triangles. You have your 30, 60, 90. You have your 45, 45, 90. Please remember these special lengths. They will always be true when you have these two special right triangles. It makes it quick figuring out these values. But in trigonometry, you're going to see why these become very important in the near future, knowing these special right triangles. So that is it. And next time we meet together, we will be going over more problems involving special right triangles.